x. It just said p of x. So that's what we
Yeah, it's called the AP edition, which means
Legal.
some of the long answers are modeled after past AP questions. Like this one, you would actually find an AP-BC exam that had this exact same graph, but I think it was for the fourth derivative instead of the fifth derivative, something like that. Now, you guys got really confused yesterday with letter B, right?
Oh no, I mean I get it now. Yeah, that's funny.
So,
No, it's negative 1.
y is the sixth derivative of 0. Y is the sixth derivative of 0, negative 121.
That's the
It's
pattern.
the coefficient is the negative 121 times x to the 6 over 6 to the x, whatever it's called.
Factorial.
Factorial.
6.
I was like, what are you talking about?
Right?
Yeah.
What is 720? 6 factorial.
Oh.
So then we just compare the two. We say, okay, if this is the general term for this position and we have a specific term for that position, all we have to do is compare to be able to solve, right? Does that make more sense, guys?
Yeah.
So therefore we can say negative 121 fits the position of the sixth derivative of f.
Oh, right.
What we're solving. So, yeah. Now, letter C goes on to say, let p sub 4 be the fourth degree Taylor polynomial for f about x equals 0. Okay. Using the information from the graph of the fifth derivative of f of x, absolute value, which means maybe it does something like this funny instead, but it's been flipped up absolute value. Anyway, it's not the point. Show that, hey, who's this guy?
He is the R.
Isn't that the remainder? Right? F would be the actual, p sub 4 would be the polynomial approximation. So if I do the approximation minus the actual, that's the error, that's the leftover, that's the remainder. They say show that the remainder is less than 1 over 3,000. Now, don't go taking this number and doing anything with him. Hold on to him. He's just a clue. We have to say, what do we know about the remainder of any power series? Well, the remainder has to be what?
Equal to. Oh. Equal
Well,
to.
remember, the remainder does have to equal for some z within, in this case, what would it be?
0 to. 0 to
It's
1
an x interval, yeah, 0 to 1/4. So for some z within and including the closed interval from 0 to 1/4, the remainder will equal, but that is not what we are showing because we don't know when that'll happen because we don't know the actual function value. This is probably a non-calculator problem. So,
Yeah, it is. It's great.
So, we can't plug in sine of x squared plus cosine of x at 1/4 and find a precise answer. So therefore, we're not going to say equals, we're going to say less than or equal to. Now, Gerardo, I know you had that question last night, just hang in there with me. I double-checked with a friend of mine that also teaches BC and has for a while. I double-checked with multiple people online. Problem is there is some discrepancy, but after looking at all the AP answers, the one that seemed to disagree and just show less than and not less than or equal to, in context to a direct application of Lagrange, was from 1999. All the rest since then have been less than or equal to that I have found. Okay, so the remainder is less than or equal to, okay, how does this go?
Absolute value of f of 5.
Because we're doing the fourth degree, right? So it's n plus 1. The fifth derivative of.
Through f of x plus
All over
5
times x to the, and there's no x minus c because it's just centered at 0, right? Now, hold on, wait a minute. What do we know about our remainder? Is it just our remainder of x or is it our remainder of 1/4? Are we just going to put a general x?
No.
Or do we actually plug in something? Yeah, right? So the fourth polynomial of 1/4, the function at 1/4, the remainder of 1/4. Does that make sense? So what am I going to plug in the x spot? Now where do I go from here?
C should be going forward because that's maximum.
How do you know that?
The middle point.
If I zero in on the portion, remember this is 1, so here's 1/4. The graph is strictly increasing, so therefore, for all the x values between 0 and 1/4, 1/4 will maximize, right? Does that make sense? So I go ahead and say sweet. So r sub 4 of 1/4 less than or equal to, what do I have down below? Absolute value, I don't have any negatives, I can ignore that. I have 4 to the 5th, bless you, times 5 factorial. On top, wait a minute, how do I know exactly what that is?
This is the slope. So you go up one. So yeah, we can do something. Zero.
We can try to think slope. Do we have any point? This is going by 20s, right? It would be about 30-ish. If we're trying to say less than or equal to, do we know for sure it's 30? What do we know for sure it's less than? So we could, for instance, in Gerardo, here's one reason why it may be less than. Our book especially plays it safe, so instead of making a guess on some of theirs, they will say, well, to for sure make sure that it's less than, and that it might not be above, because that would kind of counter the whole statement. They might overestimate. Does that make sense? Instead of being super precise. Because for instance, if we were to plug this into our graphing calculator, we could theoretically expand and find the 5th derivative of this function, and we could plug in 1/4. But the long story short of it is that we're not going to like the 5th derivative. But maybe there would be another way to think about the 5th derivative. I actually need to research this a little bit. I wasn't quite ready for what I'm guessing plugging in 40. But the other way, couldn't you see this as the function, right, the Taylor polynomial? And couldn't you take the 5th derivative of the polynomial? That'd be interesting. Meaning, when you take the 5th derivative of that polynomial, that f of x is equal to 1 plus x squared over 2 plus x to the 4th over 24 minus 121 x to the 6th over 720. We can keep on going because we technically have more terms up above, right? If we want to be super precise and we were stuck without our calculator, just don't want you guys to be completely unable to proceed. What would be the next one? X to the 10th over 5 factorial. Question, kiddos. What would happen if I took 5 derivatives of this series? Couldn't I derive term by term? First derivative, who's gone? That guy, right? And I end up with f prime is equal to, when you bring down the 2, what happens to the 2? It cancels. Maybe you should rewrite these with factorials. It might be a little bit easier. 24 was 4 factorial, right? And 6 factorial. Okay. So when we bring down the 2, that cancels. I just get x. When I bring down the 4, what do I get? Right? When I bring down the 6, what do I get?
125 or 121 x.
x, right?
Yeah.
Bring down the 8, I'd have x to the 7 over 7 factorial. I think I see a pattern. Bring down the 10, I end up with what? 2x to the 9 all over 4 factorial. I already kind of did some simplifying over there. What happens if I take f double prime? F triple prime?
Plus x squared over 2 factorial minus x to the 4 to the 4 factorial plus x to the 6.
Could I basically just start ignoring? If I'm going down to the 5th. The 1 canceled. Who else is going to cancel?
Everything's up.
That's going to cancel. That's going to cancel. That's going to cancel, right?
Yeah.
Because first derivative, that's a cube. Second derivative, that's going to be a square. Third derivative is going to be an x. Fourth derivative, constant. So I don't have to worry about.
The only thing that lasts is the 121.
Yeah. So the 6th degree became a 5th. The 5th degree became a 4th, and I still have the 121. This guy's going to become an x to the 6 over 6 factorial. This guy's going to be an 18. 4 factorial remains. Take the next derivative, 4 is going to pop down. I'm going to have x cubed over 3 factorial. Uh, 4 doesn't go into 18.
Oh, yeah.
Never mind. You're good. Over negative 121 plus x to the 5th over 5 factorial. I'm just going to forget this last term because he's pretty big and intense. We should do dot dot dots. Negative 121 x squared over 2 factorial. Negative 121 x, the 2 comes down, right? That comes down x to the 4th over 4 factorial. X cubed over 3 factorial. If I'm trying to find the 5th derivative such that x equals 1/4, three times 2 is 6. 1/4 cubed is 64.
35. Negative 35. 2-ish. X plus x squared over 2.
X, we could say negative 30 point, that'd be 25, right?
Oh.
Plus, and then we have 1 over 3/8, which we could do if we really wanted to, which ends up being 0.002. So we could actually, technically, couldn't we use even like 35 and be for sure that we're not going to go beyond that, right? Because isn't the error just going to be less than the next term? The next term is even going to be smaller than that. So we could even guess something like negative 31. So it depends on what degree of accuracy they want. This is number 34. 40 is for sure okay. We could go ahead and even make it something like 35 or even 32. Depends on how accurate. But whatever one we choose, like whether we show the reasoning as to why we can do 32, or we can just use the graph because they told us to, we can say, sweet, it looks about 30, so I'll make it less than 35, or if you actually show the reasoning, you can say less than 32. Either way, when we go ahead and solve, what does that mean? R sub 4 of 1/4 has to be less than 4 to the 5th, that's going to be 16, 16, 256. 256 times.
It's 1,044.
Yeah, 1,024, good. And then 5 factorial would end up being 120.
That's small.
Wait, that's horrible. How are they expecting us to think through? Question, kiddos. Who is 32?
Isn't it f prime f fifth derivative f c?
Who can say it's 4 squared times 2?
Oh, ha
Do we necessarily have to get all the nasty big numbers in order to be able to do it? So could we say r to the 4th of 1/4 is less than? That would go ahead and simplify with that to make a 4 cubed, right? We could technically even simplify out the 2 and say 1/2 times 4 squared times 5 factorial. True?
Yeah.
Then we could go ahead and say 4 squared is 16, 16 times 2 is 32, and 32 times 120 is a little bit easier, right? Just for sake of time, even though I'm sure you could do it. You would have 1/3840. Question, why is it good to have anything in the 3000s? What were they asking at the very beginning?
Has to be less than 1/3000.
Has to be less than 1/3000. If we were to instead, which I didn't do, but if we were to do 40 divided by, just if we did use the graph and we used the upper bound, we'd have 4 to the 5th times 120. We would end up with 1/3255, which is still less than 1/3000. So therefore we could go ahead and say, sweet, since this guy is less than 1/3000. That's it, I'm done. And why are we using less than?
Because we don't know for sure.
Because we didn't know for sure. We were using the graph to approximate, or you could use the 5th derivative of the polynomial if you want to get even more precise. But guys, even just using the 40 on the graph, they chose this one quite a bit off of the actual remainder. Does that make sense? Sorry, it's freezing right now. But they chose this one quite a bit off of the actual remainder so that we could go ahead and use the graph to approximate and proceed. Gerard.
There is no 5th derivative because it's 0. So wouldn't it when you have to use wouldn't the n plus first term be?
I mean, 5th derivative is 0. We just found the 5th derivative and it had a value.
No. Well,
I know it's phased out.
no. In A, it was 1 plus x squared plus x to the 4th. I mean, it's nice. 1 minus x squared.
That's the 5th derivative of 0, bud. We're doing the 5th derivative of 1/4.
Duh.
That makes sense.
Wait, no, because isn't it still centered as 0?
Yeah, but we're plugging in 1/4
For the derivative.
for maximizing the Lagrange. Does that make sense?
Yeah.
So, kiddos, hold on. Give me a second. Yesterday when we were doing, it actually did come back. I didn't think it would. Can you guys go back to the other book example we did yesterday before we go back into our notes handouts? I want you to answer the question for me. Should it be less than or equal to? Now, we already did ours. I want you to look at theirs and see what they did. I ended up choosing their example on purpose. I wanted you guys to be able to compare how we did it with how they did it. For the alternating series bound, that was pretty straightforward. They even used scientific notation, whatever. For letter B, they went ahead, solve. They found 2/1 plus c cubed, which is what we found as the 5th derivative. They plugged in 0.1 because that was their x value, solve. Now, hold on. I want you to check out letter B. We solved this one yesterday together. True? We figured out r is less than 0.000333. Okay? We used our calculators, hardcore. Not hardcore, but we did use our calculators, right? What did they do? They actually solved that expression when c was 0? No. They made a generic comment, and this isn't quite as clear as maybe the next one, but they made a generic comment and said, hey, if c is in between 0 and 0.1, and I double-checked, and as far as my records and my teaching from math professors, and my friend also teaches the same way, and what we see on the AP, this should be c is greater than or equal to 0, less than or equal to 0.1. Should be a closed interval, which is why we're doing what we're doing. I disagree with this statement. However, I do agree with the idea of, hey, Even if c goes a little bit bigger, like between 0 and 0.1, that just means this denominator gets a little bit bigger, this whole thing gets a little bit smaller. So they're saying for sure, the error is less than the absolute value of. Then they go ahead and solve. But what they're doing is more of an intuitive approach. I actually want to go down. Do I keep doing it with this one? Oh, there we go. They're doing it this one as well. They're seeing this value, 2.3 over 4.8, which is what they were able to solve for using their clues up above. If the question states that the derivative is less than, we're going to be using less than, not less than or equal to, because we have to keep in line with what they've given us. They haven't given us a less than or equal to. So we can say less than. That's another time when less than would be appropriate. But they went ahead and said, well, 2.3 over 48, that's all well and good, but that's gross. What is 0.05? And they figured out it was 2.4 over 48. So they're comparing in order to be able to prove what has been asked. So whenever the AP or whenever a question tells you, show that it's less than, they are not telling you an exact value that you have to solve for. You're going to find one, and you should be able to show that it's less than whatever is the one that they've given. Okay, so that, once again, that's when less than is an appropriate time to use it. Coming back here though, if we were to go to the next example, am I on the last example? I am. Here we go. Example number 2 in your worksheet. Example number 2 in your worksheet. Nice thing is calculator is permitted, so we're going to be actually finding decimals. It says to find the maximum error. We can say the maximum error equals. We're not going to be saying less than. We're going to be saying equals for letter A. And then for letter B, we're going to be saying, hey, it's less than. Do you guys notice it? This is AP-ish. Do you see the less than or equal to? Right? We just got to be careful of our signs. Use your special Maclaurin series for letter A. I'm going to freeze it and go, and then we can compare. Joyce, if you want, you can pause it and then check.
the R.
I'm doing a fifth degree, so then my remainder would be r sub 6.
Yeah. But why is it that we do how do I word this? Bless you.
Just as a Maclaurin series, wouldn't there be no sixth derivative? It's 0.
At 0, there wouldn't be.
But we're not at 0.
Isn't between 0 and 1, isn't the derivative of, well, question though, who is your sixth derivative?
Some. No.
Have you found him? Well, the first derivative is cosine. The second derivative, every even derivative, is going to be a sine back to sine again. So if you think about it, first is cosine, second is negative sine, then negative cosine, then positive sine, then positive cosine, then negative sine. But either way, it is a sine, and since we're doing the absolute value, the sign is irrelevant, right? SIGN. So think about sine. In between 0 and 1, what is sine doing? Well, 1, is that greater than pi over 2 or less than pi over 2? Less than pi over 2. So therefore, sine is strictly increasing. So if we're trying to maximize the sixth derivative, maximize sine, what's going to be the maximum of sine on the interval 0 to 1? 1. Since sine is an increasing function. So we're not evaluating at sine. We're not evaluating at 0. We're evaluating at 1. So we can say r sub 6 of 1, or the maximum r sub 6 of 1 is equal to sine of 1 all over 6 factorial, which is already positive anyway, which would be sine of 1. 6 factorial would be 127/20, right?
Do we put sine of 1 into our calculator?
It is a calculated problem, true.
That's strange that they want us to do the error using something we just estimated.
Well, remember what I just said though? What I said was back in the olden days, they wouldn't have used sine of 1. What would they have used? They would have been like, well, let's just be safe, and what's the maximum value of sine? Well, we know that sine equals 1 at pi over 2 and sine equals 0 at 0, so let's just use 1. They wouldn't have used sine of 1.
Oh.
So they would have used just 1, which they could have found without having to actually use a calculator. And they would have said, okay, 1 over 6 factorial, or 1 divided by 720. And some people still do it that way just to show like the idea. Ironically, that would still be 0.00138888, so it would still round to 0.001. So whether you use sine of 1 or whether you just use whatever, sine is maximized at 1. And remember, that's just being safer than sorry, kind of like our using 40 instead of 32 or even 31. So we can be more precise because we are able to use our calculator, but the idea is also still there that we could have been maybe a little bit off in the sense of, well, let's see, tenths, hundredths, thousandths, 10,000ths place would have been different. But still, it's pretty accurate. Does that make sense? So then on letter B, when it says, huh?
Actually, I plugged sine into the calculator, and that's exactly what we're off, 0.001. Because we got 0.842, and sine of 1 is 0.8414.
Which I rounded, so maybe we would have maybe been a little bit more, but. So in letter B, when it says use your answer to A, we can go ahead and, guys, can't we do cool stuff like maybe stow stuff, right?
Yeah.
We can assign this guy to be A, maybe assign this guy to be B. So we can say, therefore, sine of 1 is going to be less than or equal to. Now, if we had just done, instead of sine of 1, if we had just done 1, couldn't we just say less than? We wouldn't even have to say less than or equal to because we'd be over approximating. So that's another reason why sometimes you might use or might see a less than, because maybe they would have done the spirit of the Lagrange error bound. might not want to use their calculator, but we could do a plus b on one side, we could do a minus b on the other side. We were pretty precise. So we'll do less than or equal to. I would actually store the whole thingamabob, or just go scroll up and grab it. I wouldn't do the rounded version. Remember, we don't want compounded error. So on the upper bound, we would end up with sine of 1 is less than or equal to 0.843. Oh, I didn't round though. Oh, did I steal the wrong one?
No, you're good. 0.8428.
I stole the wrong one. I stole 1 over 720. Not the sine of 1, 1.
Still 0.842. Still 0.842.
Oh, that's true. We can round to 3 decimal places. And then on the other side, I'll get 0.840, right? And technically, since we're rounding, we might be able to once again make these not or equal to's because we just kind of went a little bit higher and a little bit lower than it was even indicated. So then in this case, Gerardo, you could once again make them less than because of our rounding, but either way.
But it says close.
Yeah.
So they want, I think they want.
Oh, thanks. Good call.
I don't understand. If we want finite interval A to B such that A is less than sine of 1 and B is greater than sine of 1, why did we do minus and plus B?
Because remember, R is
because it's minus B, sine of 1 minus B.
R is the absolute value of A minus sine of 1 is less than or equal to B. Remember, that's where all this comes from.
Yeah.
Sorry, I just kind of skipped to the answer. So, question from all of that craziness. Look at them. They're being super clear, super obvious, as long as you have some sort of idea. Letter C, could sine of 1 possibly be 0.9? And the answer is?
No.
Heck no. Why?
Not even close to them.
Yeah. Does that make sense, guys?
Hold on. It's just you confused me for a second because you put R as absolute value of A minus sine of 1.
It could be sine of 1 minus A or A minus sine of 1. Remember, the sign is irrelevant, the order is irrelevant, it's its absolute value.
Right.
And when you divide by a negative, all the signs will flip.
So if it was sine of 1 minus A,
It would end up being the exact same thing.
you'd add the A over, right?
You have to be able to divide by a negative, so your inequalities would. Well, you said sine minus A? Yeah, you add the A. And B is negative, B is positive. It's the exact same thing, so it's right in the middle.
Okay.
Does that make sense? Okay, so example number 3. Oh well, we'll just finish. You know what? Let's just skip ahead to example number. You guys will be fine for example number 3. It's very similar to example 2. And this is just, remember, it's just giving you hopefully a better understanding of Lagrange so that when you get to homework, you know what's going on. True? One of your homework problems, I think, doesn't it show the clue, the whole F and F prime and F double prime? Yeah, and
I
A-dubs.
think there was one like that.
Cool. So let's go ahead and just look at example 4 just so that we have something to go off of. Is that cool?
George, you have a question?
How far is everything get to the next section? If not, like, how far does this put us behind?
But I have combined 10.4 and 10.5 because technically they both have to do with convergence, and the hardest thing in them is the convergence and divergence tests that we already do. So we might be able to do both of them.
Okay.
It's possible. Because I only did it in one section last year. Okay, letter A, write the third degree Taylor polynomial for F. Use the definition. Let me freeze it. You guys have clues up above. Use the clues wisely. Joyce, I'm going to pause the video, that way you don't have to like go through awkward silence waiting for me. Check real quick, I'm going to stop the recorder fast, but remember, Z is just what maximizes. So we don't actually have to find C, take what they say is the maximum value, plug it in, and say, dun, 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 dun.
But if they don't give it to you.
If they don't give it to you, then they better give you a function. This one, it was all clues all the way.
Yeah, but if they give you a function,